Welcome to today's lesson on 8.5c. Our lesson target is I will look at scatterplots to compare bivariate to different sets of graphical data. So basically we're looking at scatterplots to compare graphs, right? And then our essential question is how can you describe patterns of association in a scatterplot of bivariate data? So this is something new. So we're not going to be able to answer this essential question at the moment, but by the end of the lesson we should. Okay, so we have a lot of new vocabulary. The first one, of course, being bivariate data. So bi, as in bicycle, means two, right? Vary, as in varies, right? Changes or is different, or variety or variable is also in that word. So bivariate data means data for two variables, a dependent variable, which is usually our y, and an independent variable, which is usually our x, that are related. So if we're talking about x and y, this is actually not a completely new topic because we've just been learning about x and y's, coordinates, ordered pairs, all that stuff, right, for linear relationships. Then, of course, you can see that our next word is linear relationships. So bivariate data has both linear and nonlinear relationships. Linear being a straight line relationship between two variables, nonlinear being a relationship that is not a straight line when graphed. So the output does not change in direct proportion to the input. Then, of course, we have the word scatterplot. So scatterplot, we were introduced to it when we learned about functions, and we had to decide whether certain graphs were functions or not, and one of the types of graphs were scatterplot graphs, not just the graphs with lines through them. So a scatterplot is a set of points plotted on a coordinate plane. Then, of course, we have the line of best fit, or the vocabulary words. So that is a straight line that establishes a trend of scattered points that is used as a prediction tool. Okay, so most times our line of best fit is actually going to be the same thing as our trend line most times, right? If it's a straight line, if our trend line happens to be a straight line. Sometimes our trend line is not a straight line. Okay, so for a trend line, that's a line on a graph that shows the association or the general direction between the data set. So now we're going to talk about association. So an association, at least in math, is a pattern or relationship identified in a scatterplot of a two-variable data set. And then a positive association is when the independent variable increases, the dependent variable also increases. So remember, independent variable is our x value and dependent variable is our y value, so both of them are increasing. So this can be related back to when we learned about positive slopes, right? If I drew a positive slope or an example of a line with a positive slope, you can see that as my x increases, so does my y. So then I'm going to draw an example of a negative slope. So I'm going to label my graph x and y. This is an example of a negative slope, which is very similar to a negative association, because in a negative association, as the independent variable increases, the dependent variable decreases. So again, independent variable means x. So as the x increases, the y, decreases. And so if I drew trend lines for each of these associations, right, each of these scatter plots, my trend line is going to go through as many points as I can possibly make my line go through. Okay, so for the positive linear association, you can see that it looks like a line with a positive slope, right? For this one and this one. For a negative linear association, you can see that the trend line, or the line of best fit, is similar to a line with a negative slope. For nonlinear association, you can see it's a line, right? But it's not a straight line. It's a curved line, like this. And no association is actually considered a type of nonlinear association, because nonlinear just means non-straight line. And so there is no line that we can draw that will go through like all these points, right? And if we drew a line, you're going to see that it looks kind of crazy, right? So that's why this one has no association. Okay, so we have some more examples of linear associations. So remember, for a positive linear association, my trend line shows that both the x and the y value, or both the variables, are increasing at the same time. For a negative linear association, you're going to see that as one of the variables increases, the other one decreases, right? So in this case, as the y, or the independent variable, increases, the y, or the dependent variable, decreases. As the X, I meant increases, the Y decreases. Okay, so we have on the side right here, I can draw a line, a horizontal line, to go ahead and show my line of best fit. Because again, my line does not have to be proportional. It does not have to be non-proportional, right? Because this positive linear association looks similar to a proportional line, and this negative linear association looks similar to a non-proportional relationship, but it doesn't need to be either. Your line of best fit just needs to go through as many points as possible, right? And so these right here, these positive linear associations are considered strong, as well as the negative linear association, because most of the points are clustered together. Sometimes you'll have points that are further apart, something like what I'm adding to the graph, and there's still a positive linear association because you can see as the X values increase, so does the Y values. But when the points are more scattered around the line, or it's, more spread out, then it would be a weaker association. Okay, so back to this horizontal line. If you guys remember, when we talked about horizontal lines, the slope would be 0. And then let's draw another graph. Okay, so if I had a scatter plot like this, and I went ahead and drew my trend line, it would probably look something like this. My trend line is vertical, right? And so when I have a vertical trend line, my slope is going to be undefined. So I just wanted to remind us that these are further examples of linear relationships, right? And this connects back to the slopes. Okay, so these are examples of nonlinear relationships. Remember, no association is considered a type of nonlinear association. So over here, we have what looks like a U. And then for this one, we have what looks like half a U, right? Maybe the right side of a U. And that's for exponential relationships. Okay, so now we have our activity. It says, analyze each scatter plot shown. We have to determine whether the scatter plot shows a linear association. And if there is a linear relationship, we have to determine whether it has a positive association or a negative association. And lastly, we have to state the association in terms of the variable. Okay, so first off, for each of these graphs, I'm going to draw a trend line. So again, I'm trying to go through as many dots as I can, or as many points as I can. Okay, so for A, you can see that the graph is comparing the height and weight of soccer players. Along my x-axis, you can see that's the height. Along my y-axis, that's the weight. So my line that I drew, my line of best fit, or my trend line, is linear. And you can see that it's positive because it's going up, right? As the x increases, the y also increases. So it's a positive linear association. And so now I have to write a statement using the units in the variable. So as the height increases, the weight also increases. Okay, for this graph on the right, you can see that it's talking about wait time and movie attendance, right? And so along our x-axis is the time waiting in line. Along our y-axis is the movie attendance. And you can see through my line of best fit, or my trend line, that this looks linear. It looks like a straight line. So it's a linear, but instead of a positive association, it looks more like a negative association because the line is going down. So it's a linear negative association. And then, of course, now I have to write a statement comparing the units in the x and the y. So we have as the time waiting in line increases, the movie attendance decreases. Okay, so we have a few more graphs. We have 4 more. So this top left one says student grades in homeroom 6. And then along the x-axis, it's the grades in math. Along the y-axis is the grades in art. And I am unable to draw a trend line here because the points are kind of just scattered everywhere, right? So I'm going to say this is a nonlinear association. And it's not even like I can draw a curved line through the points. So I'm going to be more exact or more specific and say that this one has no association. Okay, then for the one on the upper right, we are comparing temperature in Fahrenheit and Celsius. And we have on the x-axis the temperature in Fahrenheit. On the y-axis, the temperature in Celsius. So I'm going to draw my trend line. And you can see this is a strong association, right? Because I can make a straight line that goes through all the points. So I know that this is linear, and I also know that it's positive. Okay, so along my x-axis is the temperature in Fahrenheit. So as the temperature in Fahrenheit increases, the temperature in Celsius also increases. Okay, so now we have this lower left-hand graph, height of ball tossed into air. So I'm going to draw a trend line, and my trend line is curved, right? So if my trend line is curved, that is a non-linear association. And lastly, we have this graph over here. So this graph is for the height of the tide for one day. And you can see along the x-axis, we have the time in hours. Along the y-axis, we have the water level in feet. And I'm going to try to draw a trend line. And you can see this trend line looks like a wave, right? Or maybe like a roller coaster. So it's not linear because it's not a straight line. Okay, this we do is asking which scatter plot does not, keyword not, suggest a linear relationship between x and y. So if it says not linear, that is the same thing as non-linear. So we have answer choice 1, 2, 3, and 4. So you can see on all of them, they have a straight red line, right? You can see number 1 has a weakish association because not all the lines are, or not all the dots are on the line. You can see it has these points and they're close to the line, right? But they're not exactly on the line. But it is linear. And then for number 2, you can see that there's a straight red line, but actually this looks more like a curved line, right? That relationship, that trend line. So this is looking like number 2 is going to be our correct answer. Let's compare number 3 and 4. Number 3 is straight linear, right? Like all the points, it's a strong linear relationship. All the dots are on the point or on the line. And then for number 4, you can see that, again, this is a strong linear relationship because all the ordered pairs, all the dots are on the line. And remember, for lines that have vertical, or for the slope of vertical lines is always going to be undefined. Okay, so our answer for this problem is going to be number 2. So since 2 does not suggest a linear relationship between x and y, then 2 is the answer. Okay, our next we do is now asking for which scatter plot suggests a linear relationship between x and y. So now it's asking for a linear relationship. So we're looking for a straight line. So I'm going to try to draw trend lines where I can. Okay, so number 1, I know right away is not the answer because I can't even draw a trend line, right? It's just all the dots are scattered everywhere. So it's no association. Number 2, my trend line looks a little curved, right? So I could draw a trend line, but it doesn't look linear. Number 3, I have a linear line, but then I have this point out here which is going to be called the outlier. So the outlier kind of stands out. It's away from all the other points. And lastly, we have number 4, which again, I drew a trend line, but it doesn't look to be a straight line. It looks kind of curved. So my answer for this problem is going to be number 3. So the rest of the worksheet is going to be you-dos and independent practices. My suggestion is while you guys are doing it, make sure that you guys are highlighting whether you're looking for linear or nonlinear. And also, when you can, go ahead and draw a trend line. You don't need to force it, right? Like for something like this graph right here, A, the answer choice, it's no association. So you don't need to try to draw a line. And remember, the line does not need to be proportional. The line does not need to be non-proportional. It just needs to go through as many points as possible. And that is all for today.